So for our final example, we're going to add two little awkward things in. The first is that we've got some limits. We're running between 1 and 2, so we need a definite integral. And the second is that we're doing ln x, which is something that previously we couldn't integrate, but actually we can sort that out with a bit of work now that we know how to integrate by parts. So as we've started every other example, I just want to remind ourselves of the rule. So the integral of u dv by dx is equal to uv minus the integral of v du by dx. This is our rule, and we need to set up what is u v du by dx and dv by dx. And we saw earlier when we did our example of x ln x that setting up dv by dx as natural log of x doesn't help very much, because the whole point of this is we don't know how to integrate it. So ln x can't be the dv by dx, so the ln x term must be u. The question is, what's it being multiplied by? Because this thing doesn't look like a product at all, it's just ln x on its own. At this point we need to just remind ourselves that everything is a product of itself and 1. This is just 1 multiplied by ln x. And so we can take our u to be ln x and our dv by dx to be 1. And that's great because those things are easy to manage. If I have u as ln x, du by dx is 1 over x. We just know that. That's definition. If I have dv by dx is 1, I have to integrate that, and I get v is just x. So I'm sorted. I have u and v and the two derivatives. I can apply the rule. So the integral of natural log x is uv, which is going to be x ln x, minus the integral of v du by dx, so x multiplied by 1 over x, so x over x. Oh, that's just 1. So that's very easy because I need to integrate 1 again. That's not too hard. So this is x ln x minus x plus some constant. So I've done that in general, but I also now need to do it as a definite integral. I need to apply my limits. So if I'm integrating between 1 and 2, what that means is I have x ln x running between 1 and 2, and then I have x running between 1 and 2. The constant goes, obviously, because we've got a definite integral, but you've got to be really careful here. The uv term is a separate thing from that second integration. So when I'm doing my substituting in, I substitute between 1 and 2 for the uv term, and then I substitute between 1 and 2 for the x term, the integral, separately. They're not all one thing that I'm substituting into all at once, because at this point I have two separate terms. This one is no longer needing integration, so this one's already kind of done, and this one does need integration. It's treated separately. So now I just need to substitute my 1 and 2 into here. So I have 2 ln 2 minus 1 ln 1, take away 2 minus 1. Natural log of 1 is 0, so this term becomes 0. So my answer is 2 ln 2, take away 0, and then minus 1. And I'm finished now, and I can't tidy that up anymore. It asks for it in terms of ln 2 anyway, so I'm sorted. So in summary, we integrate by parts by pulling apart the product rule and kind of reverse engineering it, just like we have done with a lot of our other differentiation rules. The goal is to get a product where one of the things is easy to integrate and one of the things is easy to differentiate, because that allows us to kind of rewrite it in the other order. And ideally, in either integrating or differentiating, one of those two things becomes simpler. Usually the u becomes a simpler thing when you derive it, because differentiation is simplifying a lot of the time. And once you've done that, you get an integral which is easier to manage. Sometimes you have to do it more than once because the first application makes it better but not complete. And you also have to apply limits to it. And when you do, those limits need to be applied separately to that UV term and the second integral. That is integration by parts. It is, I think, simpler to do than substitution just by virtue of the fact that it's usually a lot more obvious what your U and V are. When you get a substitution question without being told what the U is, it can be really difficult to manage because it's just not always obvious. But it's probably a slightly longer process than substitution, and it certainly looks a bit scarier because the formula's horrible. But yeah, integration by parts.